About 3.8 billion years ago, the rain of meteors and rock bodies from space ended, allowing our planet's surface to cool and solidify. Water vapor in the atmosphere condensed and fell as rain, creating oceans. These changes created the conditions for geochemical cycling, flows of chemical substances between reservoirs in Earth's atmosphere, hydrosphere, water bodies, and lithosphere. The solid part of Earth's crust, Earchean atmosphere, was a mix of gases including nitrogen, water vapor, methane, CH4, and CO2. As discussed in Section 6, atmospheric oxygen. Free oxygen did not accumulate in the atmosphere until more than 2 billion years after Earth was formed. Volcanoes emitted CO2 as a byproduct of heating within the Earth's crust. But instead of developing a runaway greenhouse effect like that on Venus, Earth's temperatures remained within a moderate range because the carbon cycle includes a natural sink, a process that removes excess carbon from the atmosphere. Warmer temperatures speed up the chemical reactions that take place as rocks weather, and increased precipitation may flush water more rapidly through soil and sedimentary rocks. This creates a negative feedback relationship between rock weathering and climatic changes when Earth's climate warms or cools. The system responds in ways that moderate the temperature change and push conditions back toward equilibrium, essentially creating a natural thermostat. For example, when the climate warms, weathering rates accelerate and convert an increasing fraction of atmospheric CO2 to calcium carbonate, which is buried on the ocean floor. Atmospheric concentrations of CO2 decline, modifying the greenhouse effect and cooling Earth's surface. In the opposite instance, when the climate cools, weathering slows down but volcanic outgassing of CO2 continues. So atmospheric CO2 levels rise and warm the climate. This balance between CO2 outgassing from volcanoes and CO2 conversion to calcium carbonate through silicate weathering has kept the Earth's climate stable through most of its history. As a result, our planet's climate has fluctuated dramatically, but it has never gone to permanent extremes like those seen on Mars and Venus.